Hello guys, welcome to the next class of limits. In the last class, we have covered up to logarithmic limits. Till this point, we have covered. So, in this class, we'll discuss from limits of the form infinity by infinity. See, guys, first of all, whenever you have limit x tend to infinity, fx by gx, where f and g are polynomials. Let us say degree of fx is n, degree of g of x is m. Then, if n is equal to m, then the limit value will be an by am. What are an and am? An and am are the leading coefficients of fx and gx respectively. For example, if I take f of x as say 2x square plus x plus 4, then the leading coefficient here will be 2. Okay, leading coefficient is the coefficient of highest degree term. So if n is equal to m, the limit value will be an by am. If n is more than m, the degree of numerator is more than degree of denominator, the final answer will be plus or minus infinity. And when n is less than m, that means the degree of denominator is more, then the limit value will be 0. So these three cases you directly remember, it will help you solve many problems. We'll discuss the proof also, how do we get this thing. And for other problems where these are not polynomials, what do you have to remember for infinity by infinity kind of problem? Whenever we have infinity by infinity form, divide or take common out the most dominating term. Divide or take common out the most dominating term. For example, if we have x cube and x square, we can say x cube is more dominating. So in each question, we'll have to see what is the most dominating term and we either divide by that or we take it out common. Let us see both these things with the help of an example. We have limit x tend to infinity x cube plus 2x square plus x plus 4. Divide by 2x cube plus 4x plus 5. In the numerator, we see most dominating term is x cube, so we take x cube common. In the denominator, most dominating term is x cube, I take x cube common. Now, x cube will get cancelled out. Here we get 1 plus 2 by x plus 1 by x square plus 4 by x cube. Denominator you get 2 plus 4 by x square plus 5 by x cube. Now if x tends to infinity, so 2 by x will become 2 by infinity, which will be 0. So basically every term where you have x or x square or x cube in the denominator will become 0. So this value will just be 1 by 2. Here x cube got cancelled out. So you get this answer be 1 by 2. You see then if degree of the polynomial were same, the final answer is just ratio of their leading coefficient. In the numerator, coefficient of x cube is 1. In denominator, coefficient of x cube is 2. So answer finally is 1 by 2. Now what would have happened if the degree of numerator was more? So see, if degree of numerator is more, when you like when you have the terms outside, let us say the numerator it is x cube, denominator say it is x square. Okay, when you take the highest, the most dominating term outside, let us say the numerator is cubic, so it will be x cube here, denominator is quadratic, so it will be x square here. So this value will come out to be like a finite number, just like this problem. But here one x will be remaining in the numerator, which will make the whole thing infinity. So if power is numerator is more, there will be extra x left in the numerator. And if power of denominator is more, there will be one extra like there will be extra x left in the denominator. And when you put 1 by infinity, you'll get 0. So I hope all three cases are clear here. When both the degrees are same, you get a finite answer. If degree of numerator is more, you get infinity or plus or minus infinity. And if degree of denominator is more, you get 0. Okay, now let us try some problems on this. So give it a try, guys. Just try the first problem again, and do not try to use LH rule blindly in every problem, because some problem you can solve with LH, but after a time, questions will get too typical to use LH rule. So learn how to use other methods here. If you just rely on LH method, you will not be able to solve a problem of means advance. So learn how do we use other techniques. Okay, now pause the video and give this problem a try. Let us start discussion now. So the answer for this problem is 33. You will see that numerator will be a degree 6 polynomial, denominator will be a degree 6 polynomial. Here, coefficient, leading coefficient. Here you get x power 6. Next you'll get 2x power 6. Next will again be x power 6. So coefficient of x power 6 will become 1 plus 2 power 6 plus 1. In the denominator, it will just be x power 6 and x power 6. When you expand the brackets, you don't need to expand fully. This first term we need to see. It will be x power 6 here, x power 6 here. So coefficient will be 1 plus 1. When you divide them, you get 33. So the answer for the first problem is 33. Okay, now let's try the next problem. So limit x tends to minus infinity. Limit x tends to minus infinity. Square root of x square plus 4x plus 9 divide by 2x plus 7. The square root is over whole thing. Okay, guys, you can give it a try. Let us start discussion now. Answer for this problem is minus 1 over 2. See, those who could not solve, just keep this thing in mind. Whenever you have a problem of x tends to minus infinity, you put y as minus x and make it y tends to positive infinity. Okay, solving a problem in positive infinity will be better. Otherwise, you'll make some mistake. So I'll just put y as minus x here. So x was tending to minus infinity. So y will tend to plus infinity. You get square root of y square minus 4y plus 9 divided by minus 2y plus 7. Now the most dominating term here is y. Here will be like y square inside the root. So we divide by y both side. You get square root of 1 minus 4 by y plus 9 by y square. Here minus 2 plus 7 by y. You see all these terms will be 0. You get answer to be square root 1 by minus 2. So answer is minus 1 by 2. I hope this problem is clear to all of you guys. Next one. Next problem we have limit x tends to infinity e power 2x minus e power x plus 3 by e power 2x plus 4 e power x plus 2. Okay, take a pause, give it a try. Let's start discussion now. So the answer for this problem is just 1. What you can do here, see the most dominating term here will be e power 2x. Divide by that. You get 1 minus 1 by e power x plus 3 by e power 2x. Divide by 1 plus 4 by e power x plus 2 by e power 2x. When you put x tends to infinity, all these terms will become 0 because e power infinity will be infinity. So final answer will just be 1. I hope it is clear, guys. Next problem. Now this is a very important problem. We have a fourth problem as limit x tend to 0 e power 1 by x plus e power minus 1 by x divided by e power 1 by x minus e power minus 1 by x. Give it a try, guys. Let's start discussion. First, very important thing you have to see here is when they say limit x tend to 0, this thing is not same. If I say limit x tend to 0 positive, you see when x tend to 0 positive, 1 by x will tend to positive infinity. e power positive infinity will be infinity. And when x tend to 0 negative, then 1 by x will tend to minus infinity. And e power minus infinity will be 0. So these 2 points we have to see. So that means we have to put limit x tend to 0 positive and x tend to 0 negative. When we see x tend to 0 positive, we have e power 1 by x plus e power 1 by e power 1 by x divided by e power 1 by x minus 1 by e power 1 by x. I just divide by e power 1 by x both sides because it is the dominating term. Its value is infinity. So we get 1 plus 1 by e power 1 by x square, 1 minus 1 by e power 1 by x square. You see this e power 1 by x tend to 0 positive infinity. So 1 by infinity will be 0, 1 by infinity will be 0, so you get just 1. In the next case, when x tend to 0 negative, again we have same thing here. E power 1 by x plus e power 1 by plus 1 by e power 1 by x, e power 1 by x minus 1 by e power 1 by x. In this case, we multiply with e power 1 by x because 1 by like this e power 1 by x is 0. So if I multiply with e power 1 by x both sides, you get e power 1 by x square plus 1, e power 1 by x square minus 1. You see this thing will be now 0. So 0 plus 1 by 0 minus 1, you get minus 1. You see RHL, right hand limit was 1, left hand limit is minus 1. So we say limit does not exist. I hope this question is clear to all of you guys. Next. Now this next is also a good problem. Limit x tends to minus infinity x power 5 into tan of 1 by pi x square plus 3 mod x square plus 7 divided by mod x cube plus 7 mod x plus 8. Give it a try, guys, then we'll start discussion. Let's start now. First of all, like we discussed earlier, if x tends to minus infinity, I'll put x as minus y. So y will tend to plus infinity, get minus y power 5 tan 1 by pi y square plus 3y square. Mod x square will become mod y square, which will be just y square because y now is positive. Plus 7 by y cube plus 7y plus 8. Now the most dominating term here looks like y cube, so I just divide by y cube. What will happen here? If you see here, like when you divide by y cube, this y square will be left. I'll take the minus outside and then write the y square as 1 by y square. Because inside tan we have 1 by pi y square. So I take this 1 by y square, now divide by 1 by pi, multiply with 1 by pi. So this thing will become tan fx by fx, and then fx will tend to 0. No, because when you put y as infinity, this thing will tend to 0. So tan fx by fx will be 1 when fx tend to 0. So this will just become 1. Next will be 3 over y, which will again be 0. 7 over y cube, which will again be 0. Denominator will be 1 plus 7 over y square, which will be 0. 8 over y cube, which will also be 0. So finally we get minus 1 over pi. I hope it is clear to all of you guys. Next. This next problem I'll discuss myself. This is some extra concept here. This is let the sequence Bn of real numbers satisfied. Bn plus 1 is 1 by 3, 2 Bn plus 125 by Bn whole square, and Bn is not equal to 0. And find the value of limit n tends to infinity Bn. What logic we use in this kind of problem? We say when limit n tends to infinity, Bn plus 1 will be almost similar to limit n tends to infinity B of n. So we refer both of them as B only. So when n tends to infinity, we see they are almost equal. So we refer to them as B. So when you take limit n tends to infinity both sides, so this all will become B only. So get B equal to 1 by 3, 2B plus 125 by B square. So B will just be equal to 5. Okay, this is this problem. Nothing much to think here. That's all. Next one. Next, we have the problems where we get infinity minus infinity form. Like this is one of them. So I'll discuss the first problem myself, then next you can try. So when you have infinity minus infinity form, let us say first problem is limit x tends to infinity, square root of x square plus kx minus square root of x square minus kx. You see, when you put x as infinity, this will be infinity, this will also be infinity. So it's infinity minus infinity form, but we can't cancel it out. It's not like infinity minus infinity is zero. Infinity is just a large number. That doesn't mean they're same number. So what do we do here in this kind of problem? We rationalize first. When you rationalize in the numerator, you get x square plus kx minus x square minus kx. In the denominator, you get root of x square plus kx plus root of x square minus kx. Now this x square get cancelled out. You'll get 2kx here, no? Now it is at infinity by infinity form, so most dominating term here will be x. We divide by x. In the numerator you get 2k, in the denominator you get root of 1 plus k by x plus root of 1 minus k by x. And when x times infinity, this will be 0, this will also be 0, so you get 2k by 2, which will be k. I hope it is clear, guys. So next time you see this kind of problem, just rationalize. Okay, try this on the next problem yourself. So limit x times to infinity, square root of x plus square root of x plus square root x minus square root x. Give it a try, guys, then we'll start discussion. Let us start now. We have infinity minus infinity form. So we rationalize. When you rationalize, you'll get this thing to be x plus square root of x plus square root of x minus x. So this x and x get cancelled out. In the numerator, you get root of x plus root of x. In the denominator, you get root of x plus root of x plus root of x plus root of x. Now the most dominant term here will be root x only. So we just divide by root x both sides. See, when you divide by root x, it becomes 1 plus. Now this will be root x by x. So inside the root, if you take, you get x by x square, which will become 1 by root x. So you get square root of 1 plus 1 by root x. In the denominator, this will become 1. This will become root of 1 by x. And when you take again inside, it will become x power 4. So you get the root of 1 by x cube. It goes like this, is x plus root x by x square, which will become root of 1 by x plus root x by x square. And root x by x square will be root of 1 by x cube plus 1. Now, wherever you have x in the denominator, that all the terms will become 0. So you get just 1 by 1 plus 1, you get 1 by 2. I hope it is clear, guys. Let us see the next problem. See, limit x tends to infinity. Root x into root of x minus 2007 minus root x. Okay, this square root is our whole thing. Give it a try, guys, then we'll start discussion. Let's start now. Again, infinity minus infinity form, we rationalize, we get minus 2007 by root x minus 2007 plus root x. Here also we have root x. Now divide by root x both side, we get minus 2007 by square root of 1 minus 2007 by x plus 1. So this thing will become 0. We get minus 2007 by 2. I hope it is clear, guys. Next. Next, I'll give you an extra concept here right now, which you can use directly, and the proof of this we'll discuss later with miscellaneous problems. For now, I'll just tell you what is the shortcut here. If ever you have limit x tends to infinity, nth root of x plus a1, x plus a2 up to x plus an minus x. X tends to infinity, nth root of x plus a1, x plus a2 up to x plus an minus x. You see this infinity minus infinity form. The answer for this problem will directly be arithmetic mean of all these numbers. A1, A2, A3 up to AN. If you take arithmetic mean of all of them, that will be your final answer. So in this case, we have A1, A2, A3 up to AN. So arithmetic mean will just be sum of them divided by N. That is all. You can note down this thing. This proof we'll discuss uh, in the end in miscellaneous problems. So there I'll discuss this proof with the help of series expansion. You will see in one step we can prove this thing. For now, you can use this thing directly. Okay, let us try one problem on this thing. You see the problem fourth one, limit x tends to infinity, cube root of x plus 1, x plus 2, x plus 3 minus x. So what will be answer here? So the answer for this problem will just be arithmetic mean of 1, 2, 3, which is just 2. So 1 plus 2 plus 3 divided by 3, it will just be 2. Okay, guys, you can use this thing directly for this kind of problem. Like I told you, proof we'll discuss later. Next, try one more on the same thing. Limit x tends to infinity, fourth root of x minus 1, x minus 2, x minus 3, x minus 4, minus x. So what will be answer here? So the answer here will be minus 5 by 2. In this case, we'll take arithmetic mean of minus 1, minus 2, minus 3, and minus 4. Because I told you x plus a1, here x minus 1, so a1 will be minus 1 here. So minus 1, minus 2, minus 3, minus 4, arithmetic mean of them, it will just be minus 5 by 2. I hope it is clear, guys. Let us go to the next one now. Next, guys, we have more problems on some miscellaneous problems on limit tends to infinity. Whenever you have limit tending to infinity and you have some random problems, see how do we solve them. First one of them is this. Now, this is an important model of problems. You will see this thing many a times. So just directly remember this thing. Whenever you have this kind of problem, limit n tends to infinity, 3 power n plus 4 power n plus 5 power n whole power 1 by n. Whenever you see this kind of problem, the final answer will just be the greatest number out of these. What are numbers here? 3, 4, 5. Whichever is the greatest number, that will be a final answer. So in this case, answer will be 5. How do we see that? See, the highest number you take common out. So 5 power n I'll take outside. See, right now you will see it will be infinity power 0 form. If you put n as infinity, you get infinity, infinity, infinity. So infinity power 0 form. So what we do is just take the highest number common out. So 5 power n will take outside the bracket. So 5 power n, when you take out of 1 by n, you get 5 only. Here you get 3 by 5 power n. Here you get 4 by 5 power n plus 1. And now we discuss if a number lie from minus 1 to 1, its power infinity will just be 0. So 3 by 5 power n will be 0. 4 by 5 power n will also be 0. So we get 0 plus 0 plus 1, so it will become 1 power 0. 1 power 0 will just be 1 only. So the final answer is just 5. Okay, so like I told you, remember answer will always be the greatest number. That's all. Next time you see this problem, directly you can write. Okay, next one, guys. This next problem you can try yourself. We have limit n tends to infinity, n power a plus sine square n factorial divided by n plus 1, where a is some real number between 0 and 1. Give it a try, then we'll start discussion. Let's start now. What we do here is we divide by n power a. So numerator will become sine square n factorial divided by this will become n power 1 minus a. This will become 1 by n power a. See, sine square and factorial, no matter what is the value, it will always lie between 0 to 1 only. Denominator, see, n power 1 minus a, a is between 0 to 1. So you can say 1 power a, 1 minus a will be some positive number only. And infinity power something positive will be infinity. Next, 1 by n of a. Again, n of a is some positive number, a is some positive number. So you get 1 by infinity power something positive, which will be 1 by infinity. 1 by infinity will be 0. So you get a finite number divided by infinity. So finite by infinity will be 0 only. So the final answer will just be 0. Okay, next problem. We have limit n tends to infinity n into 3 power n divided by n into x minus 2 power n plus n into 3 power n plus 1 minus 3 power n equal to 1 by 3. Find the range of x. So limit is given here, you have to find the range of x. Give it a try, guys. Let us start discussion. In this problem, see, the most dominating term will be n into 3 power n, so we divide by that. Here n into 3 power n we have. Just divide by that. See what do you get? You get 1 by x minus 2 by 3 raised to power n plus 3 minus 1 by n. So in the numerator you already get 1, in the numerator you have 3 and this term. So 1 by n will obviously be 0 because n tends to infinity. So now in order to get this thing to be equal to 1 by 3, we can say this has to be 0, no? And something raised to power infinity will be 0 if that something lie between minus 1 to 1. So x minus 2 by 3 lie from minus 1 to 1, you get x minus 2 lie from minus 3 to 3. Add 2 both sides, you get x lie from minus 1 to 5. I hope it is clear to all of you guys. Next problem. This next is a very good problem. You will see this in some typical exams. We have limit n tends to infinity minus 1 power n plus 1 sine of pi into square root of n square plus 0.5 n plus 1 where n is a natural number. So good problem, guys. Give it a try. Let us start discussion now. First of all, if you just take n infinity here, you will get sine infinity whose value we cannot find out. So what we do here, we use this trick first of all. Sine n pi minus theta we can write as minus 1 power n plus 1 of theta. You see, when n is even, it will come out to be negative. And when n is odd, it will come out to be positive. That is why minus 1 power n plus 1 theta. So for even negative, for odd positive. So this thing is in this form right now. So we can take this whole thing as theta and we can write this as sine n pi minus theta. So get sine n pi minus pi of this thing. Now you see inside sine we have infinity minus infinity form. So we just take pi common out and rationalize the remaining thing. When you rationalize this n square get cancelled out, then you will see the most dominating term will be n. So we divide by n here. Okay, you will get minus 0.5 minus 1 by n by 1 plus square root of 1 plus 0.5 by n plus 1 by n square. Here you will see that wherever you have n in the denominator will become 0. Finally get minus 0.5 by 2 which will be minus 1 by 4. So you just end up with sine minus pi by 4 which is minus 1 by square root of 2. So that is all for this problem. This is a good problem, guys. So make sure you do this thing properly. Okay, next we have series expansion. So what we'll do is I'll just give you this series expansions right now. So this you have to remember always. Now this is very, very important concept. Many advanced level problem or the typical problem of mains also We can solve those problems in one step using the series expansion. All the proofs, like I told you, we can prove this thing later with the help of series expansion. All those also can, whatever formula we have discussed till now, we can prove all of them using series expansion. So these are very, very important. So to solve these problems, first you need to know what are the series. So this first one, log 1 plus x. You see, whenever you see log here, by default, base will be e only. So log 1 plus x will be x minus x square by 2 plus x cube by 3 minus x power 4 by 4 up to infinity. Okay, you see a pattern here, so it will be helpful to remember. E power x 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Sin x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus so on. Next cos x 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial and so on. Next tan x. For tan x, there is no pattern here. So what you do is just remember the first three terms. More than that will never be required. So first term is x, next is x cubed by 3, next is 2 by 15 x power 5. So remember it always. Next is tan inverse x. It's x minus x cubed by 3 plus x power 5 by 5 minus x power 7 by 7 and so on. A power x. It's 1 plus x ln a plus x square by 2 factorial ln a square and so on. Now this 1 plus x power n, this is again very, very, very important. It is 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 n minus 2 by 3 factorial x cube and so on. Now if you have done the chapter binomial theorem, you will see it is nothing but it look like NC1. This is like NC2. This is like NC3. But we don't use n here, like we don't use NC1 here because NC1, NC2, NC3 are only when n is natural number. Here x could be any power, it could be any rational number. N could be 1 by 2, minus 1 by 2, minus 4 by 5, anything. N can have any rational value, and one condition on x here, x should lie between minus 1 to 1 only. So this series expansion we can use only when x lie from minus 1 to 1. Okay, we'll discuss this thing in detail in binomial theorem also. So if you do not know about this right now, just remember it for now. Later on, we'll discuss this thing. But this is very important. Okay, so these series expansion, guys, you all need to remember always. And for now, I'll just give you one formula that we discussed earlier. Let us see how do we prove it using the series expansion. Limit x tend to 0, sin x by x. We discussed was 1. Let us see how we can say this thing. We expand sin x here. You see sin x will be x minus x cubed by 3 factorial plus x power 5 by 5 factorial and so on. Divide by x. So this x will get cancelled out with all the x in the numerator. So we'll be left with 1 minus x square by 3 factorial plus x power 4 by 5 factorial and so on. Now if you put x as 0 here, directly get 1. That's all. So you see here all the other terms are of no use because when you put x as 0, they all become 0. Okay. Now from next time, until what term you have to expand a series, you see in the denominator we have x only. So in the numerator also only x will be of any use. All the other terms will later become 0 only. So you can expand something up to that power of x which you see in the denominator. So if only x power 1 is in the denominator, you could expand sin x just up to x only. Because all the other power which you take will be of no use. X square, like x cube, x5, all were of no use. If the denominator was x cube, so I would have expanded x minus x cube by 3 factorial. If it in the denominator is x power 5, we expand up to x power 5 by 5 factorial. Okay, you'll get more idea when we discuss more problems. For now, just remember you expand up to that power of x which you see in the denominator. That's all. Keep this in mind. Okay, so problems on this thing we'll continue next class. So wait for the next lecture. We'll continue the problems of series expansion, and then after that we'll discuss some miscellaneous series and sandwich theorem, 1 power infinity, 0 power 0, and infinity power 0. So all this we'll cover in the next class. Okay, guys, then bye for now.